This is Unit 6, Video 3, Intermolecular Forces. Now that we understand polarity, can determine if a molecule is polar or nonpolar, we can understand the force of interaction between two molecules. That's what we're talking about, intermolecular force. What is the force of interaction when two molecules come together? If they're polar, they're going to tend to stick positive to negative. Dissimilar charges attract each other, okay? If it's nonpolar, then the question is, how is that going to interact? And that's what we want to explain here. So nonpolar molecules still have fluid electron motion. So electrons are moving. We don't totally understand that motion, but we know they're moving. The nonpolar molecule is where a molecule, say we've got two centers here, and it's nonpolar. So we've got a distribution of electrons here, something like that. We bring up another molecule here, and we have the same distribution of electrons. But the electrons are moving, so there's a random chance that we get an ever slight positive charge here and negative charge here. When we do, it will induce a dipole in the other molecule, creating a positive here and a negative here, meaning when the electrons are a little bit more here, they're going to tend to go away from it over there. That's going to create a tiny attraction. Now this attraction is not centralized to 2 points like that. It is random throughout the molecule. So as two molecules come together, there's this random motion of the electrons. We randomly get positive and negative all throughout the molecule. The next one above will be doing the exact same thing. They'll correlate and interact with each other. It's not a very strong force. We need large molecules. And obviously the strength of it's going to increase as a molecule has more and more surface area. If we have a dipole, as I said, we're going to get fairly simplistic. Now we have two atoms, and this one is slightly positive, this one's slightly negative. So when another one comes up, we're going to get them to orient in the opposite direction, meaning they're going to flip, and then they're going to stick. So this stickiness is going to be right there between the charges and the dipole. So the final type is going to be hydrogen bonding. When I have a molecule that has a hydrogen attached to a high electronegative element, such as, in this case, methanol, we have this type of setup here. You can tell that will have a dipole. There's a dipole vector there. This OH here is going to create a high electronegative difference between the two atoms. And the hydrogen is tiny, tiny, tiny. That nucleus is basically one proton. So it is the smallest of all the atomic particles in terms of elements. Well, when it comes up to another methanol, maybe like this, this hydrogen will dock into these lone pairs. That's what we call a hydrogen bond. It is not a normal covalent bond. It's a through space interaction. Okay? So let me summarize the three types of intermolecular forces. London dispersion forces, or sometimes called dispersion forces. This is the force of nonpolar molecules because they have no dipole and they can't hydrogen bond. So we get random charge distribution creating interaction between two molecules. All molecules have dispersion forces. All, 100%. Even things with dipoles and hydrogen bonds still have dispersion forces. So this is going to be the nonpolar force. Dipole-dipole. If a dipole is present, we recognize that it is polar. So the dipole-dipole is a polar molecule. If it's polar, then we're going to get a stick positive to negative, like that, opposite charges. And this is the force of polar molecules, dipole to dipole. Hydrogen bonding. We must have a hydrogen attached to one of these three elements. Nitrogen, oxygen, and fluorine. Very high electronegative elements. Okay? One of these three. And then it begins to interact with the lone pairs on a different nitrogen, oxygen, and fluorine. We'll not interact with the same one it's attached to. It's a through space interaction.